Hello everyone, hope you are doing well. I am Akshay Parmar, Assistant Professor at LG Institute of Engineering and Technology in IT/IC department. Today we will discuss an interesting data structure topic, that is analog to digital conversion, and we will see its technique. It have the three techniques: amplitude modulation, frequency modulation, and the phase modulation in brief. Right. So let's start with the analog to analog conversion. So for that, what is the analog to analog conversions? The process of varying one or more properties of the periodic waveform to the or the carrier signal with modulating signal that contains information to be transmitted, right? So the process of the varying one or more property of the periodic waveform, such as amplitude, you are changing the property as amplitude, you are changing the property of frequency, or you are changing the phase, or you are changing the two of them, right? So that is called the analog to analog conversions, right? So that is called the modulation technique. So let's begin with the analog to analog conversions. What do you mean by the analog to analog conversions? The process of varying one or more properties of the periodic waveform, or we can say that the carrier signal, with a modulating signal that contains the information to be transmitted. It is called the analog to analog conversions. For that, we are using the modulation technique for that. So for that, we are using the modulation technique. So what is modulation techniques, right? So in the modulation technique is the process of varying one or more properties of the periodic waveform or a signal with a modulating signal that contains the information to be transmitted. Why we need a modulation, right? So need for the modulation is, with the help of the modulation, the reduction in the height of the antenna we can achieve. We are avoiding the mixing of the signal and increase the range of the communication. Yes, of course, it is increase the range of the communication. You can send the same signal far away. You can send the signal from long distance with the help of this modulation technique. Multiplexing is possible with the help of the modulation, and it improves the quality of the receptions, right? So that's why we are using the modulation, right? So what is the modulation that we have seen, and we have seen its need. For that, we are using the band pass filters, right? So what is that? A band pass filter is an electronic device or circuit, right? It allows a signal between two specific frequencies to be passed. It allows signal between two specific frequency to pass. It prevents signals at unwanted frequency. For an example, radio, right? Analog signals are modified to represent the analog data, and it is also known as a analog modulation, right? It required when the band pass is used. After that, it has the mainly three method of the analog to analog conversions. They are AM modulation, frequency modulation, and the phase modulation, which are denoted as AM, which is stand for the amplitude modulation, FM, which is stand for the frequency modulation, and the PM, which is stand for the phase modulation, right? So these are its three techniques. Let's begin with the amplitude modulation first, right? It is the simplest type of modulation. What is the amplitude modulation? The process of changing the amplitude of the high frequency carrier wave in accordance with the intensity of the signal is called the amplitude modulation, or we can say that the AM. Amplitude of the carrier wave is amplitude of the signal being modulated, right? So let's see how it's doing. So this is our input signal on which we are trying to make an amplitude modulation, right? This is our input signal. After that, we are passing and one carrier signal. After that, this is the carrier signal. We are doing the amplitude modulation techniques on these signals, right? This is the carrier signal. We are changing its amplitude with according to this input signal, right? So its amplitude will be accordance to this input signal, right? So after that, we are changing the amplitude of the carrier signal with respect to this input signal, right? So that's how we are getting that our output signal, which is modulated on the amplitude of the input signal, right? So that's how we are changing the amplitude of the carrier signal with respect to input signal, and we are getting the output amplitude modulated signal, right? So that's how we are changing the characteristics of the signal, which is amplitude, in the amplitude modulation, right? After that, let's see how we are changing the amplitude of the carrier signal, right? So for that, we are giving an input signal to the multiplexer, and other input is an carrier signal which is given by the oscillator, right? After multiplying the both the signals, we are getting the output signal there, right? So that's how we are getting the output signal. So it has a two and for the multiplexer, it has the two analog inputs, input signal and the carrier signal, and output proportional to the product of the both of the two amplitudes, right? So first is the amplitude of this input signal and the carrier signal. The output is the multiplication, or we can say that the product of the two signals, right? So that's how we are getting the output signal in the amplitude modulation technique. If the modulation signal's frequency is increased, the amplitude of the carrier changes is the greater, right? The bandwidth of the amplitude modulated signal is twice bandwidth of the modulating signals, right? So 2am is equal to 2b, right? So bem is equal to 2b, right? So after that, let's see an advantages of that amplitude modulation. It is simple to implement technique, right? It can be the demodulated using the circuit consistent of the very few component, right? So whenever we are trying to demodulate the signal, the circuit or the components are lesser required, right, in this technique, amplitude modulation. This is all about the amplitude modulation. After that, let's see in frequency modulation. What do you mean by the frequency modulation? In the frequency modulation transmission, the frequency of the carrier signal is modulated to follow the changing voltage level of the modulating signal. Or we can see that changing the voltage level is an amplitude. The peak amplitude at the phase of the carrier signal remain the constant, but as the amplitude of the transmission signal changes, the frequency of the carrier signal changes accordingly. Let's see how the frequency modulation is working. For that, this is the input signal on which we are trying to get a frequency modulation, and this is the carrier signal, right? So we are changing the characteristic of this carrier signal. So we are changing the characteristics frequency of this carrier signal with respect to this input signal, and we are getting an output signal. So we are changing the characteristic of this carrier signal with respect to this input signal, and we are getting the output signal which have the frequency modulated, right? Here you can observe that in this output signal, the frequency of this signal, the frequency of this carrier signal is changed, and we are getting the output signal who have the frequency modulated with respect to this input signal. Here you can observe that in the positive phase, the carrier frequency is the high, where the zero to negative portion is there. There are the signal which have the lower frequency, right? After that, whenever the signal is having the positive side, it is having the higher frequency, like that we have changed the we can say that the modified the characteristic of the frequency to modulate this channel, right, modulate this signal, right? So that's how we are changing the carrier signals property frequency with respect to this input signal, and we are getting the output signal, right? So that's how we are changing the behavior, or we can say the characteristics of the frequency, right? This is all about the frequency modulation. After that, let's see an phase modulation. In the phase modulation, the phase of the carrier signal is modulated to follow the changing voltage level of the modulating signal, right? So in the phase modulation transmission, the phase of the carrier signal is modulated to follow the changing the voltage, right? So here the changing the voltage level is none but amplitude, right? So the peak of the amplitude and the frequency of the carrier signal remain the constant, but as the amplitude of the transmission signal changes, the phase of the carrier changes accordingly, right? So you can see that the phase of the carrier is changes accordingly. We are changing the amplitude and the frequency in the transmission, right? So in the frequency modulation technique, we are changing the frequency of the signal only. we are not touching the amplitude or the phase of the signal in the frequency modulation technique, right? So let's see how the frequency modulation technique is working with by one example, right? So let's see it by one example. So here is an one input signal on which we are trying to do a frequency modulation. For that, this is our input signals, right? And after that, this is our carrier signal, right? So we are changing the frequency of this carrier signal with respect to this input signal, right? So here in the frequency modulation technique, we are changing the frequency of this carrier signal with respect to this input signal, right? So how we are doing that? So for that, we are changing the frequency of that, right? So for the positive side of the input signals, we are for the positive side of the signal, we are representing it by a frequency carrier signals frequency which have the higher frequency, right? And whenever we are representing the negative side of the signal, input signal, we are changing its frequency to the lower, right? So that's how we are changing the frequency of the carrier signal, and we are representing that same input signal with a carrier signal, right? So for after changing the frequency with respect to the input signal, we are getting the output signal, right? So here you can observe that in the positive side of the signal, the frequency of that signal is higher. Whenever the negative part of the input signal is encountered, that is represented by the signal which have the lower frequency, right? You can clearly observe that. After that, whenever the positive side of the input signal is encountered, then it is represented by the signal which have the higher frequency, right? Like that, right? Like that, you are representing the output signal, right? And that's how you are converting the output signal with respect to the input signal, right? So that's how you are converting the input signal, and that's how you are modulating the signal on the frequency modulation, right? So this technique, it's broadly used in the radio transmission, right? Whenever you are hearing a radio song on the radio, they are using the FM, right? Frequency modulation, right? So right after that, let's say in phase modulation. So in the phase modulation, we are changing the phase, right? So in the phase modulation transmission, the phase of the carrier signal is modulated to follow the changing the voltage level, right, of the modulating signal. As you can observe that we are changing the phase whenever the amplitude of the carrier signal is changing. The peak amplitude and the frequency carrier signal is remain constant, but as the amplitude of the transmission signal changes, the phase of the carrier changes accordingly, right? In the phase modulation technique, if the signal is changing its frequency or phase, we are not to worry about, but whenever the it is changing its amplitude, we are changing the phase of the carrier signal, right? So let's see it by one example. This is our input signal on which we are trying to do a phase modulation. We are changing the phase of the carrier signal with respect to its amplitude only, right? So for that, whenever the positive side of the signal is encountered, we are having an one kind of phase, and after that, whenever the negative side of the negative side of the signal is encountered, we are using the different phase difference, right? So in our technique, we have used the 0 degree phase difference for to represent the positive side of the signal, and we have used the 180-degree phase difference to represent the negative side of the negative side of the signal, right? So that's how we are representing that input signal with respect to the phase modulation, right? So for that, as we have discussed, for representing the positive side of the signal, we are using the signal which have the 0 degree phase difference. After that, to represent the negative side of the signal, we are using the 180-degree phase difference signal, right? So that's how we are using the signal who have the 180-degree phase difference. After that, the positive side of the signal is encountered. So for that, we are using the same method. We are representing it by a signal who have the 0 degree phase difference, right? So we are representing it by 0 degree phase difference. After that, the negative side is there. So we are representing by the 180-degree phase difference, and that's how we are modulating the carrier signal with respect to an input signal, right? So that's how whenever the positive side of the signal is encountered, we are representing by an 0 degree phase difference, and whenever the negative side of the signal is encountered, we are representing it by an 180 degree phase difference in our example, right? So this is all about the phase modulation. That's how you can change how you can modify the phase of the signal, carrier signal, to represent the analog signal, right? So this is all about the phase modulation or modulation techniques. We have seen the analog to analog techniques, right? So in that there are the three techniques: amplitude modulation, phase modulation, and the frequency modulation, and we have seen brief with the example, right? We have seen them with an example, right? So that's all about today's session. Thank you for the watching.